Welcome everyone. Today we have our another new episode and we will discuss on the advance in Nikola Tesla technology in 21st century. We have our world famous speaker, Professor David Smith. He's going to discuss about the new innovations and new technologies. And he is a problem solver. So hopefully his guideline will be helpful for our country. First, Mr. David Smith, what you want to discuss for the new innovations and especially focus on Nikola Tesla?
Great, thank you. Great, thank you. This is our, I think, fifth or sixth time to jump into Nikola Tesla, and I love his innovations. I love the elements of it, but more importantly, I love looking at his processes and what he's done and how he's done it, and that he had. The I've tried to think of some of the newer things that we've seen with him and to use today, and I will begin to use them. He's really a visionary who was outside of his time and really looked at how to put things in place and how to begin to uh, make a difference, but then he had problems making a difference. Uh, he is known for his work on things like alternating current, the Tesla coils. He is known for being one of the first ones to do wireless remote control of vehicles and things. And he also uh, was a futurist beginning to look. In fact, one of the things that I find very fascinating about him is in an interview with the Caller magazine in 2026. He predicted that the solution of our problems does not lie in destroying, but really in mastering machines. And that in the 21st century, this will reverse this order. So he is actually saying back and saying that the machine is actually going to help us begin to master some of our life and what we're doing. And if we look at where we are in the use of AI and other things, part of his prediction back from 1926 is becoming true with what we're doing today. And while many of his predictions were not always accurate, his work really continues to inspire scientists and engineering today. And many of his inventions, such as the Tesla coil and the AC motor and alternating current and things, are still in use today, well after the time uh, that he had died and passed away. Uh, and we're seeing that really come true as we're looking at what he's doing. The other thing that I find really, really interesting with him is that all these years later, uh, he has built very, very important uh, technologies that are there and how they're used and how there's alternate times for conflict. There just recently was a legal case where uh, Nikola Tesla had patented some of the some electrical distribution currency material. Edison protested his patent and had it awarded to him. And recently, the family of Nikola Tesla has had that patent overturned and given back to him again, decades and decades and decades after he had passed away. So the legacy and the intellectual property are still hanging on and uh, going forward. He was a mother had a lot of influence on him. His father actually was a priest who wanted Nikola Tesla to be a priest, but he really went into the first things that he invented was a dynamo that was an electrical generator but when it was reversed, it could be a electric motor. And those are things that have continued to keep on going and keep working. And uh, when he worked in Budapest for the telephone company there, he really began visualizing the principle of rotating magnetic fields and developed plans for an induction motor that would actually become the first to use the alternating current that he later invented. Uh, but right after he was working on direct current power plants, and that's kind of what brought him to the United States, was working on those power plants. Uh, and he was competing against Thomas Edison in that area. And he ended up going into a partnership with Westinghouse. And that was really beneficial for him because Nikola Tesla's big criticism was that he was an inventor, he didn't commercialize what he did. He would invent it, and then uh, he couldn't take it to market. He began to protect his intellectual property, but he just really didn't have the skill set to take it to market. And that is one of the challenges you see even today with most companies, is it's really hard to things that the more so as we move to future in there. Um, and, you know, there is a lot written about the battles between Tesla and particularly with Thomas Edison, and but the battles between direct current. Uh, and the two men were very different. Edison had a uh, almost a genius view on how to make practical inventions almost immediately available for market, where Tesla's interests were far ahead of his time. Uh, his ideas could not be implemented for years or even further in the future. So that is where you saw a lot of them coming with that. Um, and in one of the interviews with Nikola Tesla, he actually told the reporter, "It seems that I'm always ahead of my time." And he went on to say that he's not as concerned about being proven right in things, but his most important thing is the invention and making sure that he could get it out and include other things that could work on it. And he was that, he wants to make us where every man, every person could use his inventions down the road. And, you know, that has been really proven well. As you again, very interesting advances is he actually filed multiple patents for different things, from his Tesla coil. In fact, his last patent that he filed was a patent for aerial transport. In the United States, he had over 112 U.S. patents. He also had another over 200 worldwide countries. And uh, over out there. And the Tesla Foundation, though, estimates that he had well over 300 patents across the world. And that the most protected ones was his pump, and those were granted patents over 22. His view for intellectual property is pretty good. Look at most of them were not commercialized by him and ended up being commercialized for others. So if I come back and just stop a second, IBM's top invention. You heard me in this one already. It's the Tesla coil, and the Tesla coil has both a practical use. Oh, it's got a fantastic entertainment use. We've all seen these coils that look like they're shooting out bolts of lightning. That's almost what it is. That was one of his inventions. And it's really a transformer used to produce high voltage, low current, high frequency, alternating current electricity. And it's a multiple system which are connected by a spark gap. One of the places he wants to use this is transmitting power around the globe. And it needed more than this, but the concept of the Nikola Tesla coil is also used in broadcasting and radio telephony and many other differences there. But I still like to see the coil shoot out. But the complementary technology to the Nikola coil Tesla is his magnifying transmitter. And like I said earlier, Tesla had intended the Tesla coil to be part of a wireless power distribution system, which companies today are still working on using the same basic principle. And many of them have now demonstrated the ability to transmit wireless powers for 1,000 miles through the air. But to make it work even better, he had to produce what is called his magnifying transmitter, which he used it and combined with this Tesla coil to transmit the power as a magnifier. Uh, and so instead of with the Tesla coil, where a lot of the energy of that discharged the Earth, what the magnifying transmitter did is it created standing waves of electrical energy, which could be used by a tuning circuit. Uh, Going further with his focus on power, he invented the Tesla turbine, which is a motor system, as opposed to the pistons going up and down to make it. He developed his own turbine style system that made disc rotate instead of turbine going up and down. Very, very interesting. His efficiency on this was as high as 90%, uh, which is really exceptional considering that just some of our are now reading at efficiency level.
Thank you. Thank you,
Tesla
Mr.
also
Dev.
was working. No, go ahead.
Please continue. Continue.
I can keep some of it if you want me to.
Yeah, there is some
Um,
sound broke, so that's why I'm requesting. Please continue.
yeah, yeah. So also he was an innovator in X-rays, and he created something called the shadow graph, and he probably produced the first X-rays that were in the United States when he used to use a vacuum tube to obtain an image of Mark Twain. So instead of a image of Mark Twain, he got pictures of the camera and the screws and things, and then he later on did that changes result between him and Marconi, which got there first. But a Tesla used a Tesla oscillator to transmit signals across the English Channel. Tesla invented neon light and worked it. He also, and I love the example, he had the first wide-scale hydroelectric generation. He used Niagara Falls in the United States as his source, and he worked with George Westinghouse, and They built a hydroelectric power plant there that transmitted alternating current electricity back to Buffalo, New York. Again, great inventions. I mentioned that with drones and things today actually traces itself back to Tesla in what a electrical exhibition in 1898, and with the remote control boat he built. Uh, Again, we can trace what we're doing with drones today to that. Alternating current, would not be where we are without this type of electrical current. And so, Sharif, these are just some of his outstanding inventions that are really still in use today. And and the lessons we can learn from him are very powerful as we look at this, and are ones that entrepreneurs, scientists, engineers should still be learning from today. Not only his best practices, but his worst practices. Like I said earlier, one of his worst practices is he would invent it, he would document it, but then he would never take it to market. So a lot of these ideas were left on the shelf for other people to come back and take them to market, but Tesla did not have the capabilities to do that. And for your audience, Reed, that is a great lesson learned, is that you can be a great inventor, but unless you do the technology transfer and commercialization, you're having limited impact. And oftentimes it takes partnerships, oftentimes it takes group intelligence of being able to apply these and use them and take them to market. And with today's marketplace being a global marketplace instead of the local marketplaces back in his time, uh, it's even more critical that we try to commercialize in a manner like this. So, Sharif, I think that's an introduction. It's some of his, probably 10 or so of his greatest inventions. There's many, many more, and a lot more to say, but I hope this begins to answer part of the question.
Yeah, thank you. Thank you, Professor David Smith. Nikola Tesla is a great inventor, but I have a question like, uh, why some point these great innovators do not get enough support from the society? You said that he has financial challenge, he do not have good ability to market his innovations. So a scientist, he could only do the innovations. The rest of the things, maybe his team or government agencies or the corporation can do that. So how we can protect this kind of intellectual talents for our present society? Even we find that uh, the present society, they are not big fan of highly talented scientists. They want to follow like the filmmakers, the actor, the actress, or sportsman. So how we can help this kind of scientists and innovators?
Well, you're right, is that we have a society that science has become less and less respected in. And we see how they can be used with other things. I believe we're seeing some renaissances coming back around. Everything goes through cycles, and we're seeing it doing the same here as well. Um, and we're increasingly seeing, particularly the actors and actresses, uh, being caught up in saying things that are later proven untrue. And that is going to increase the movement back towards that. The amount of disinformation in the marketplaces today is very, very high. And we have to work to undo that. The other thing is that with today's pace of invention and with today's pace of entrepreneurship, uh, we have made it look easy to transfer some of these big innovations market, and we lose sight. I mean, a good example is if you look at IBM Watson. IBM Watson, uh, when it won on Jeopardy, was a great accomplishment, but IBM Watson has floundered in the commercial workspace and has not sold well. And see, that's the challenge you have with uh, technology. There's three types of innovation you see with technology. There's incremental innovation, where you just add a few more features, functionality. There's disruptive breakthrough at the far other end, which there's very little of, and where it fundamentally changes a whole industry, a whole area. But the big one in the middle, and this is the middle of the S curve you typically see, is what's called distinctive innovation, where it's not fundamentally doing anything totally different, but it's doing things in a different way. So you have incremental, distinctive, and breakthrough innovation, which is exceedingly hard. Back in the time of Tesla and others, most of the innovations tended to be breakthrough, and they did not have a process for working on distinctive innovation. Uh, what is a distinctive innovation? Uh, it might be a way to travel without using a car, plane, or ship. So a teleconference could be a distinctive breakthrough, where a disruptive breakthrough might be something like teleporting, where you actually physically move to a place. You know, kind of like the Beam Me Up Scotty from Star Trek would be one of that area. But those innovations are important to understand, and that the fact that from the time of Nikola Tesla and Edison and Marconi and others till today, we have much more invention, but most of it is more on the incremental and distinctive side versus breakthrough. Does that make sense to your question?
Thank you, Professor David Smith. Can you hear me?
I can.
Okay, thank you for your excellent
I
analysis.
can.
Besides that, what is your advice, especially World Talent Economy Forum? We are working with university, we are working with corporations, we are working with academy. So, what is your advice for them that how we can invest more in research and innovation and how it can be benefit for our corporation, for our society?
That's a great question. Um, I'm going to answer it with several pieces. To One of the things I have studied, the people who have won Nobel Prizes in science and technology. And one of the things about it is rarely do you see a Nobel Prize go to a single individual. But what you've tended to see is in science and technology, Nobel Prizes tend to go to a group of people. And most of the time, this group of people work at multiple institutions. So they're geographically distributed. And then I have been a leader in multiple research and development consortia where the industry has come together to put consortia together, like the MCC consortia and the Cemetech consortia. Um, and what we've done with those is we've understood the power of group intelligence, and that the old adage, it takes a village to train someone. Well, it also works, it takes the group intelligence, it takes multiple villages to particularly deal with large scale innovation, large scale science. So if I'm advising you on this, one of the things is to set up environments where you can have group intelligence used. When we started the MCC consortia and Sematech consortia and National Center for Manufacturing Sciences and others, they benefited from the concept of a law we got passed in the United States called the National Cooperative Research Act. And what it did is it provided protection to companies doing research and development in pre-competitive technologies. So these are the underlying fundamental technologies that then can be used in a lot of other products. One of my pieces of advice is within places like Bangladesh and Malaysia, others like that, is to look at how you can provide protection for people working together in pre-competitive technologies. Because these are the underlying foundations that make a lot of the technologies work and move forward. Also, colleges, universities, there needs to be, and how do you commercialize technology? How do you protect your intellectual property? There needs to be really a course put in place, understanding what you've heard me very often talk about, Sharif, that everything today is a system. Unfortunately, when you look at most engineering colleges, most science colleges, and others, they tend to teach everything's discrete. But in reality today, everything's become a system. And universities and colleges need to teach that concept for entrepreneurship and for innovation to be active and alive today. Um, and it's, for me, it's one of the most fundamental things. I have been talking about that, lecturing about that for a couple of decades. And recently, some of the large universities, some of the military universities, and others have now put that in place as curriculum at the university. And it's going to be critical for understanding the future of innovation. You know, Sharif, you've heard me use the example. Your mobile device, you know, is it a phone? Is it an entertainment device? Is it a computer? Is it GPS? Uh, what is that? It's in all of those and more. You know, our mobile devices are, our smartphones now are medical devices. They are cameras. I can produce a movie just on my mobile device as well. So what industry is it in? It's in all of those. How many systems are in it? Your mobile device is made up of really hundreds of systems in it because of how it's used. That is one of the basic building blocks that we really do have to bring into colleges and universities and boot camps and things as we teach technology transfer and others. Because if we don't do that, we're going to doom ourselves to incremental advances, and we're going to be beat by the people who can think in system dynamics versus the people who just think linear. And Sharif, I think, hope that makes sense.
Yeah, excellent, excellent. Besides that, education is very important to develop more scientists, more innovators. So, what is your advice to our audience how we can develop a good education system for this knowledge-oriented society? I think country like Bangladesh, Nepal, Pakistan, Malaysia, or Middle East, many countries, Africa, they struggle a lot. What should be the good guideline? How they can produce more knowledge worker or produce more scientists and innovators? That is the key challenge for everyone.
Well, let me start in the fields you named is the Oh, well, I need to get my Portuguese working. There we go. Uh, the concept we're in today is a time of lifelong learning. And that is very important that lifelong learning be a concept. For example, my engineers, my software engineers, uh, I encourage them. Oh, I actually do more than just encourage them to continue to take online courses, to go and take boot camp training and things to advance their knowledge. The half-life of information for a software engineer is very short, very short. And same with some of the engineering in universities. In some of our engineering schools, particularly software engineering schools, what you learn as a freshman is outdated by the time you graduate as a senior. So it's the process of learning and the continuous learning um, is very important. You know, the pandemic taught us the importance of telelearning. I hope we never go back from that. In fact, it has helped us change the whole face of learning and has helped us go from transitioning and learning in a Socratic method to being much more involved. You know, 10 years ago, I would say we haven't changed the way we teach since the time of Socrates. Pandemic began to open that up and change it for us and look at how to do things in a different way. Uh, the one of the places I think we do still need to change in our education process is we need to teach how to collaborate at a distance. Uh, I've had fun with this in some of the places where I have some impact. Uh, I can tell you very often in schools, you do projects with people who are in your same class right next to you. What I've encouraged them to do is do at least a project or two where you're partners at other schools. Many times we have standardized curriculum. You should do a project at a distance with them so that you can uh, be more efficient and effective that way. Um, Other changes to education I would highly uh, advocate for is most universities are extremely protective of the research they're doing. So much so, if you've ever noticed this, when you do a search using a tool like Google, you rarely get uh, uh, results back from universities. Rarely get results back from universities. Uh, and they block them. I either would like to see universities open up more the research they're doing so that other people can look and collaborate with them. I know universities are trying to balance their budget with technology transfer, but if the majority of the Nobel Prizes in science and literature are won by people working at different institutions, it seems to me makes sense we can apply the same principle to the basic science and research that's being done in universities. For a developing nation, I would highly encourage them to work with others. I can tell you, for example, uh, even though I'm here in Austin, I collaborate with universities across the country. I'm a fellow at multiple of them. I'm a fellow at a university in Brazil, where Virginia is, who asked a comment earlier. And I do work with some other universities globally as well, because it's important to understand that. But universities need to look beyond their own region. They need to look at partnering. When I was still at the University of Texas, for example, the business school there, we set up a collaboration uh, with a business school in Curitiba, Brazil, to exchange faculty members. We then set up a collaboration when I was beginning the business school with FGV universities in Sao Paulo and Rio to exchange faculty members. And that cross fertilization of the teaching and the teaching styles worked fantastic. I would encourage the same thing as you look at universities within your regions. Look at a way to set up partnerships. Look at a way to set collaboration where the researcher, the professor, even the students get exchanged with others and cycle back. You've heard me say before, the best way to transfer technology is moving people. The same way, the best way to improve education is having people move and people do things like that. And it really is one where that whole concept of group intelligence is enhanced every time you do that. And I believe that's one of the most important or overlooked places in education today.
Thank you, Professor. This is excellent discussions. And what is your advice for the corporation who has opportunity to invest different startup, different research and innovation projects, and what is the benefit for them and for the government, like corporation and for the government to invest in research and innovation?
Well, there's many different ones. Let's talk about government first a little bit. One of the premise of government is you use government to create opportunity for your citizens. If you use it to protect your citizens, create economic development for them to apply your research and development. If I'm in Bangladesh and Malaysia, uh, you have a lot of blackish water with mangroves and things growing in around them. And those are shrinking. Government funding ways to do research and get those is very important, I think, as you go and do things uh, and have it happen. I also see, though, that the commercial interest is one where commercial companies are first off most responsible to their shareholders who have invested in them. If they're a public company, they're most responsive to their public shareholders because they have put their risk in you. But and this is one of the things that is slowing down some of the responses to greenhouse gas and others, and some of the ESG challenges. But corporations are beginning to learn into balancing that, of being responsive to their shareholders and making a profit. Uh, but they also have to become more responsive to the things that help the community and the world survive, like the greenhouse gas and others. And even though most of the time doing something in industry where the company is promoting their ESG goals, where they're trying to get to zero emission and stuff, uh, where that costs more, that decreases profits and things. They're beginning to understand the balancing act, and we have to do that. The other place I would say is help create the opportunities. Now, I'll give you an example here. When the Semiconductor Manufacturing Consortia moved to Austin, we had to start training courses around the Central Texas area to create technicians who serve that industry. We didn't have enough, and we did not have training programs here to do it. Universities and business need to come together to create the training programs that are applicable to the businesses. It'd be great to, within a university, have them graduate students that can immediately go to work in these companies. They can immediately go to work. To, um, help the company grow and be skilled workforce, because most of our workforce today is a skilled workforce. And the partnership between universities, colleges, trade schools, boot camps, and the commercial sector is all, but it's the thing that can help accelerate the economic development of a region, of a city, of a region. And that's some of my recommendations.
Thank you, Professor David Smith. What's your concluding remarks for today's session?
Well, we've learned a lot from Nikola Tesla over the years, and I personally think we have a lot more to learn too. Uh, and I love the quote you just had up there, that being a scientist, researcher, and innovator is hard and continuous work. And the group needs to have some of the same characteristics and recognize that multiple intelligence and capabilities are important. Uh, that is so true today. Uh, Nikola Tesla was a great visionary. He often invented things in his head and worked on them to his head until he had a solution, he thought, before he ever wrote them down. Just think what the world would be like today if Nikola Tesla had been a person who collaborated with others, where his inventions would have gone, how many more things he could have invented because he would have had economic support to get it done and to do those inventions. So that was one of the failures of Tesla, like I said earlier. But just think how we are in a world where we can now instantly communicate like we're doing right now, all the way around the world in real time. You know, we do not have to confine ourselves to our physical geographic location. You know, I used to say, and I still say, that geography is not a place on a map. Geography is where you find the competencies and capabilities you need to do the work you need to do. You know, you see with your programs, you can reach around the world and pull people in real time, and they make contributions. That is one of my really strong marks, is that you have to look outside of next to you. Many of our problems we're trying to solve today are global problems. They're not regional problems. You have to think globally, and you have to think of how we can do that. And the workforce is continually changing. The rapid advances in AI, the rapid advances in robotics, autonomous systems we're putting in, are changing faster than we ever thought it would. So this concept of continuing the world, way magic wand, and make an instant change, it would be that every person in your region understands the concept of lifelong learning. And if they do that, then a lot of the economic challenges go away because of those. And Sharif, I think that's probably my continuing remark there, is we live in one of the best of times, because with all this visualization, we have this instant communication, we have the power of computers everywhere. And just we as human beings need to understand our place and how to keep up, how to advance, how to collaborate, and how to use these in a way to make the world a better place. So, Sharif, thank you for letting me be today's program.
Thank you, Professor, for joining today's session. This is excellent discussion. I'm sure our audience also learned a lot of interesting things. Our friend from Brazil, Virginia, my Ritz, she actually contributed for today's session with her comments. I want to give special thanks to Virginia. And I request all of our audience, please share our content with your government agency, corporation, and academy. Nikola Tesla Technology Conference actually a innovation process, how a nation can bring more success and more progress to the society. So I request all of our audience, you have to be very much focused on research and innovation. I request all of the corporations, government agencies, and academy invest in your resources in research and innovation. It will help you a lot to bring more success. Thank you, Professor David Smith, for your continuous support for World Talent Economy Forum and for excellent discussion for today's sessions. I'm sure our audience also love your contribution today. Thank you, Mr. David Smith, and thank you, Ms. Virginia. So, if you
Well,
want to
and
join,
I love Virginia to send me more of this in Austin. My favorite drink from Brazil.
oh, okay, excellent. Thank you, Mr. David Smith. Thank you. Thank you, everyone. Thank you, everyone. Thank you. Bye bye and take care.
Well, thank you.